The table on the left is from FEMA P-1100, and these numbers right here represented in pounds, that's the pounds of force these particular brands of hardware can resist before there's a failure. So let me show you what that looks like. Say for the Simpson StrongTie HDU2, earthquake force comes up this way, and as soon as it reaches 3,075 pounds of force, this right here will fail. It pulls away. What happens is the lag screws that hold it to the framing, they pull away, and the hold down can no longer perform. And I'd like to point out that when this plan set was put together, it says development of this plan set has been reduced to 3,000 pounds. Based on anchorage to existing foundation systems. Now what they're saying there is of all the places that it could fail, of the steel rod, the wood, the tie down itself, they expect that the concrete is going to be the thing that fails. So the rest of this video we're going to be looking at that. I talked to Simpson StrongTie about this to see what they had to say, and in their calculation they determined that the actual strength of that connection is 2,344 pounds and not the 3,000 pounds in FEMA P-1100. I also talked to Hilti about the exact same thing, and they told me that the capacity was 2,422 pounds, and that is a 13% strength differential based on the ability of the concrete to resist the tension force. The values that you see here are based on 2,500 psi concrete, and the California Existing Building Code tells us that any existing concrete is only worth 1,500 psi unless tests show otherwise. Now this is based on tests that were done in the Rockwell tests in the early 70s, and if you'd like to know more about those tests, you can just click on the card above and it will explain it to you. But anyway, these values are not quite accurate based on this, this PSI concrete. And what I did is I asked Simpson and I asked Hilti, their specialists in concrete, and I said, look, can't you interpolate this and say, go from 3,500 to 2,500 and see what the percentage of difference is? And then we can apply that from 2,500 to 1,500. And Simpson said they couldn't do it, and Hilti said they thought they could do it, but then they called me back and said they couldn't do it. And so I just had to ask Hilti. I said, well, just intuitively, what do you think the change would be in capacity? From 15 to 30%. We want to err on the side of safety, so we'll use the conservative 30%. And so if we use the Simpson value, this is what we come up with. So we start out with 2,344. We subtract 702, and we end up with 1,642 pounds. So this value for the tie downs of 3,000 is probably very inaccurate. And if this is the basis of the table in P-1100, it should be reevaluated. FEMA P-1100 does have a way to check the concrete where the tie downs are, and so what it says is where tie downs are used to determine the sheath panel length required along a wall line, each adhesive anchor shall be torque tested in accordance with table R-2. Now look down here at table R-2, and it says adhesive anchors, they must be torque tested to 20 pounds with a 5/8 screw. I consulted both Simpson StrongTie and Hilti about this testing method, and this is what they had to say.